Hello, everybody. My name is Sudhanshu Pawar, and today we are going to learn about how to understand, read, and modify URDF for the purpose of simulation on Gazebo. So, in this video, basically, we will learn how to add Gazebo plugins. We will also learn how to modify our URDF model if need be, and how to read the URDF model. So, what is basically a URDF model? A URDF model means the full form of URDF is Unified Robot Description Format. So, it basically means a 3D model from Fusion 360 or SolidWorks or whatever is converted into a text file. So basically, a 3D model is described into a text file, into words, its dimensions, its weight, its origin, everything is described into words, and that is called a URDF model. So in the previous video, we converted a Fusion 360 model into a URDF model. So once we make a URDF model, I'll save it in video URDF. So you will see a folder such as this, whatever the name of the model, underscore description, you will see this. So these are the launch files, display.launch, gazebo.launch, urdf.rbs. The second is the mesh files, where all the STL files of the robot are stored. The third is the URDF. This is what we will be focusing on today. So there are 4 files over here. That is the .gazebo file, .trans file, .unsafe.chakra file, material.chakra file. So what we are interested in here right now is the chakra file and the gazebo file, unsafe.chakra file, unsafe.gazebo file. So I have opened them over here already. Yeah. So basically URDF is written in a XML format. Within the XML format, as you can see, this is the basic XML version .10 standard line for XML. So what is in a URDF file? So as I said, that the 3D model is converted into a text file. It is described in text format. So there are two things over here. First are the links, as you can see. Link. Second are the joints. So link are all the parts within the model, all the parts. That is base link, we describe base link, right wheel, left wheel, LiDAR, right? These are the things we described over there. The links are basically the components that we designed in the modeling software. We used Fusion 360 last time. So what is it exactly? As you can see, first of all, here we have included the other files such as the materials.chakra file, unsafe.trans file, unsafe.gazebo file, right? Which we saw in here. Okay, we have included those files as well. Now, what is in the unsafe.gazebo file? So, unsafe.gazebo file contains all the requirements for gazebo simulation, such as its color, its gravity, material, etc., body color, material, etc. So let's understand what is in the .chakra file. The first is the base link. This is the most important link. That is your base link, as we designed it in the Fusion 360 software. Here we will find out the origin of the model, the roll pitch yaw of the model, mass value is like 1.2 kg around. Its inertia around every axis, IXX, IYY, IZZ, IXY, IYZ, etc. That's the visual. These are the physical properties of the material, of the link. This is a visual, how the model will look like. Within the visual, we have got the origin where the model will be situated. And the second is the geometry of the model. For the geometry of the model, we call in the STL files we had saved within the meshes folder over here. Base link. Okay. Right. The material name server, collision. Again, collision is around what are the boundaries of the object, around what boundaries the object might collide to another object. That is given as collision. It is the same as visual. You can change this if you want to. but it's not necessary. Same goes for the right wheel, left wheel, LiDAR. Now the next is the joints. Now you can see revolute one joint, parent link, base link, child link, right wheel. So here the joint between base link and right wheel is named as revolute one. The type is continuous, means it is a rotating joint. Since it is a wheel, we will get the rotational joint, revolute joint. Its axis is given as -1. Same goes for the left wheel and base link. And the rigid joint. Rigid joint is given as fixed. It is the joint between base link and the LiDAR. So I hope you can understand how the URDF is written. If I make it fixed, the revolute joint will not rotate. The wheel will not rotate. But if I make it continuous again, the wheel will rotate. Or if I make this continuous, the LiDAR will start rotating if I give it an actuation. I hope that is understood. This was the .chakra file over here, not the .gazebo file. Same XML file. Now, as you can see, property has been set over here. Chakra property, name, body color, value, gazebo, silver. So basically, over here we are setting up a variable, and the value of it is given as silver. Now, as you can see within the gazebo reference base link, so gazebo model of the base link has been given the material as equal to body color. So here the color of the material or the color of the link, as you will be seeing it in gazebo, will be silver color. So if you want to change this color, you can easily give it as, let's say orange. So when you will launch the file in gazebo, the base link will be given as orange. Let's copy and paste this. Copy, paste. Now let's give wheels a black color. Wheel color. And let's give it a LiDAR color. Let the wheels be black. Let the LiDAR be, let's say, blue. Okay, I hope that is clear.
Yes.
Now what we must do is that within Gazebo, we are going to be simulating a laser scanner, a LiDAR we are going to simulate. But within the Chakra URDF, within the Chakra file or the Gazebo file, there is no mention of a laser. We have just given the LiDAR its dimensions, its mass, etc., all the physical properties, but we have not defined it as a laser. Now we must define it as a laser. How are we going to do that? So let's go to the .gazebo file. We need to add a plugin over here. A plugin is required, and you can find that plugin for a laser over here. Let's just type in laser plugin on Gazebo. You will be seeing here tutorial Gazebo plugins. All the major plugins used in your Gazebo simulations we will be able to find over here. So what we need here is a laser. Right? So let's get the Hokuyo laser. What's happening? Let's copy it. And just simply paste it over here. Now the Gazebo reference given over here is Hokuyo link. So the exact name of the LiDAR must be given over here. As you can see what I'm doing. Copy. Paste. Sensor type, GPU array, head Hokuyo sensor name. And we also need to change it here. LiDAR 1. Right? Topic name is whatever you set. Let's just change this. We are going to just keep it as laser scan. We'll set it later in the further videos. Now you can see the visualize call. So visualize is over here means that every ray the LiDAR is sending towards the objects can be visualized in the Gazebo model. I will show that to you in a little bit. I just keep it true, you will be able to see all the lines, all the rays sent out by the LiDAR during the simulation. But if I just keep it false, you won't be able to see all the rays in the simulation. And samples. So what means by samples? Let's say the LiDAR is scanning a 360-degree environment, right? Within that 360-degree environment, there are 720 rays. It's just taking 720 samples within that 360 degrees. So every degree, for every degree, there are 2 samples. Understood? 720 divided by 360 is 2. So for every degree, there are 2 samples. Understood? Now the minimum angle and maximum, this value is in radians. So as you know, 1 pi is equal to 3.14. And 3.14 in radians is equal to 180 degrees. 2 pi is equal to 360 degrees. So for a full rotation, for 360 degrees, you have 2 pi. That is 6.24 radians. As you can see, the minimum angle by default over here is given as 1.57 minus 1.572 plus 1.57. That means pi by 2 minus pi by 2 plus pi by 2. If the robot is facing in forward direction, the angle is 0. Then minus pi by 2, that is minus 90 degree, to plus 90 degree, that is 180 degrees. So this particular sensor right now, according to its parameters, is only scanning an area of 180 degrees. If we change it to 3.14, minus 3.14, let's give this 3.14. Now it will scan an area of pi, that is 180 degrees, minus pi to plus pi. Understood? So it will now scan an area of 360 degrees. It's minus pi to pi. Understood? Minus 180 degree to plus 180 degree. The next is range. So what range the LiDAR sensor will work? It is like 0.1 meter to 30 meters. Resolution, noise, Gaussian, okay. Plugin name of the plugin, file, topic name, frame name. Yeah. So in this video, we have understood how to read a URDF, how to modify it according to our needs. You can also change the mask over here, mask and all over here, types of everything. We've learned how to modify URDF according to our needs, how to modify a .gazebo file to change the colors of a link, and also we have learned how to set a specific sensor to add in a plugin so that a specific link can be used as a sensor, as a LiDAR or a depth camera. You will find multiple types of plugins over here, like depth camera, multi-camera, camera, a lot of plugins you can find over here for a lot of sensors. That is the thing. Well, that's it for this video. Thank you, everybody. Please like and subscribe to this video, to my channel. It will be of great help. Thank you so much. Bye-bye.